All right, we are on the third page of notes, and we're going to continue on with our triangles. So number 4, it says the lengths of the sides of a triangle are 2, 19, and 20. Determine if the triangle is a right triangle. So I don't know if you caught the key word sides, right, triangle. Automatic, a squared plus b squared equals c squared. Those are your clues. Okay. Remember that C has to be the largest side, which in those three sides is 20. 2 and 19, they can go in here. It doesn't matter if you put the 19 squared plus 2 squared or 2 squared plus 19 squared. All right, all we're going to do is we're going to see if these two sides are equal. We don't know if they're equal yet, but if they are, left side equals right side, it's definitely 100% a right triangle. If they're not equal, not a right triangle. Okay, so 2 squared plus 19 squared in your calculator, hit enter, and you're going to get a total of 365. On the other side, you type in 20 squared in your calculator, and out pops 400. And you're going to see that 365 is not equal to 400, and therefore this is not a right triangle. Okay, all right, number 5. Which statement about the isosceles triangle with vertex B to the right is wrong? All right, so because this is the vertex angle, that makes this and this the base angles. Therefore, this is the base. And this is a leg, and this is a leg. Okay? And on the base angles, they are the equal ones. And the legs are the equal ones. And so with that in mind, we can fill in a bunch of other stuff knowing that. So the 70 can go ahead and be borrowed over there. If you have 180 degrees in this triangle and you take away two 70-degree angles, you're going to be left with 40 degrees for the vertex angle. Since the legs are the equal one marked with tick marks, this leg would be 12. And I believe that's all we can fill in. We cannot fill in how big the base is. All right, so we're going to go ahead and go see, is angle B equal to 40? And that is true based on our picture. In number 2, is angle C plus angle B equal to 100? And the answer is false. It's actually equal to 110 degrees, 70 plus 40. 70 is angle C and 40 is angle B. And so I'm going to go ahead and hold on to this one. AB is 12. BC is 12. And that does equal 24. So that is true. And angle A is equal to 70 is also true. And I'm going to go back and pick my choice. Okay. That's how I always do multiple choice. Number 6. In triangle ABC, the measure of angle A is 15 less than twice the measure of angle B. This sounds like let statements. We don't know how big angle B is to do 15 less than twice it. So we're going to go ahead and call angle B. We're going to let that equal x so that angle A could be written as 15 less than twice angle B, 15 less. So 2x minus 15. The measure of angle C equals the sum of the measures of angle A and B. So if we go ahead and add angle A and angle B, you're going to see that those are like terms, and therefore we're going to call angle C 3x minus 15. And we could go ahead and plug those in. And you're going to realize you have all three angles of a triangle, and that all three angles of a triangle do something every single time. And what they do is that they add up to equal 180 degrees. Okay, so there's one angle, two angles, three angles. We got them all. All right, so let's go ahead and combine our like terms. 3, 4, 5, 6, that's 6x. Negative 15 minus 15 is negative 30. We're going to go ahead and add 30. We're going to get 210. And we're going to divide by 6. And x comes out to equal 35. Okay. And then I want you to determine the measure of angle B. Well, B is just an x, and so that's 35 degrees. But we can go ahead and plug in 2 times 35 minus 15. Angle A ends up being 55 degrees. And 3 times 35 minus 15. Angle C ends up being 90 degrees. And so if they asked us to classify this triangle because of the 90-degree angle, even though the triangle doesn't look it because I didn't know about that angle until I was done, but this would be a right triangle. Also, all three angles are different, so all three sides would be different, and that would be known as a scalene triangle. And that one's finished. Okay. One last one. In number 7, we have triangle ABC. And there's that good stuff again. Don't. Read over that. Make sure you mark your picture. It says that BC is one of your equal segments, so it gets a tick mark, and it's congruent to AC, who's your other equal side, who should also get a tick mark. And remember, if you have two sides of a triangle equal, you also have two equal angles across from them. So you start at one of your sides, you travel across your triangle, and bam, you found one of his equal angles. Start at your other side, walk across your triangle, bam, you found the other equal angle. Even though they don't tell you to mark them, I promise you it will pay off if you do mark them every single time. Then they tell you angle C is 64 degrees, and they want to know the measure of angle A and B. Good news, A and B are the same. So we could call them both x, and you could write up an equation, and you could say angle A plus angle B plus angle C is equal to 180 degrees. And people that like equations might want to solve that. And then there's other people in the room that say, I can do this a different way. And say, I have 180 degrees in this triangle, and I've already spent 64 degrees on the vertex angle. Therefore, I have 116 degrees left to split equally among two equal angles. So if I split 116 equally, I'm going to find out that there's 58 degrees left for each angle. And this is the same thing you would have gotten if you solved that green equation. And so we can say angle A is equal to 58. Angle B is equal to 58. Okay. If we had to classify this triangle, two equal sides would make him isosceles. And he has three, by sides, he's isosceles. And he has three angles all smaller than 90, and so he would also be an acute triangle. Again, this is based on angles, and this is based on his sides. Again, A for angles, A for acute, sides, isosceles. Hopefully that helps. All right, guys. Hopefully that you learned a lot about triangles, more than you ever wanted to. And we got more triangles on the following day. So I'll see you guys there when we get there.